Okay guys, let's look at 9-7 continued here, verifying trig identities. And that's page 516. And that's using fundamental identities to verify new trig identities. And when we're verifying this identity, we're going to begin with the expression on one side, and we're going to then use our algebraic skills and trig properties to simplify. Now, one thing we can't introduce, say, is properties of equality. I couldn't just say if I wanted to add 4 in over here, or say do the same over there. That's a no-go. We can't do stuff like that. We can't just add stuff in there, okay? Okay, so, but we can use our other algebra skills to try and take what's on the left side and make it look like what's on the right side. In other words, to get secant squared theta minus 1 over secant squared theta and make it look like sine squared theta. Well, I can start by essentially putting this over each denominator here. Okay, so then I say, oh, secant squared over secant squared is just 1. And then when we have this squared, that's essentially like 1 over secant theta squared. Well, 1 over secant theta is the same as cosine. So that would be 1 minus cosine squared theta. So 1 over secant, and I'll put the squared here because 1 squared is just 1. 1 over secant squared is 1 over secant squared, and 1 over secant squared can become cosine squared because remember cosine is 1 over secant and it applies if it's squared as well, okay? And then I say, oh, 1 minus cosine squared, that's one of my other trig identities, so that equals sine squared theta. And then notice I made it look like the other side, right? Sine squared theta. Okay, so what did I do? Well, I divided this denominator to each of my terms up here, which if it's one denominator, we can do that. And then this became 1. And this became 1 over secant squared became cosine squared. And 1 minus cosine squared is one of our identities, and so that's sine squared theta. And I proved essentially that sine squared theta equals sine squared theta. Secant of x plus tangent of x equals cosine of x over 1 minus sine of x. Okay, so we're going to take the left side here, and we're going to try and use our algebraic skills and our trig identities to get it to what the right side looks like here, okay? Okay, so first that usually begins with rewriting. Secant of x is 1 over cosine of x. And tangent of x is the same as sine x over cosine of x. Well, if these have the same common denominator, I can make that 1 plus sine x over cosine of x. Okay, and then another algebraic trick we can do is we can introduce the conjugate. Say I want to get rid of 1 plus sine x, I might introduce its conjugate, which is 1 minus sine x. Top and bottom. And if I do that top and bottom, I'm essentially just multiplying by 1. Okay, so when I do a plus b times a minus b, that's a squared minus b squared, sine squared x, over the cosine of x times 1 minus sine x. Okay, and now let's go this way. Okay, now if you look at your Pythagorean identities on 514, sine squared plus cosine squared equals 1. Well, if I subtract that sine squared over to the other side, then I'd have cosine squared theta equals 1 minus sine squared. So I can substitute cosine squared x in for 1 minus sine squared of x. Okay, and that's again for my Pythagorean identities, but of course sometimes you have to say manipulate those. Okay, and that's over now cosine of x times 1 minus sine of x. Okay, and then we'll move up this direction. Okay, now cosine squared over cosine, well, one of those cosines cancel, so that leaves me with a cosine up top. And that leaves me with just 1 cosine x up top over 1 minus sine x. Notice I got to where I'm trying to get to, cosine of x over 1 minus sine of x. And what did I do? Well, I rewrote secant as 1 over cosine. That's just your reciprocal identity. I rewrote tangent here as sine over cosine. That's my tangent identity and cotangent. Then what did I do? I can introduce a conjugate here, top and bottom, because I'm essentially just multiplying by 1. And that's what they mean by algebraic skills. Usually it means introducing a conjugate sometimes. So 1 plus sine x times 1 minus sine x is 1 minus sine squared x. And then I decided not to multiply that through here. I kept it like that, okay? And then notice 1 minus sine squared x becomes cosine squared x, and then I can cancel one of those cosines, leaving me with just 1 cosine upstairs. And then I'm in the form that I'm looking for. Okay, so it's just a process of using your identities to make it look like, say, the other side of the equation. And you can use a conjugate, or you can use your identities. And let's look at another one. Let's look at number 7 here on page 516. Cosine of x, cosecant of x, tangent of x equals 1. Okay, so let's see what we can do here. Well, maybe I leave cosine x as it is. Cosecant is the same as 1 over sine of x. And tangent of x is sine x over cosine of x. Well, let's see. Sine over sine cancels. Cosine over cosine cancels. Remember, that's over 1, essentially. So all that just simplifies to 1, and 1 equals 1. Okay, easy verify. How about, let's do another one here. Okay, how about we do 6 on 516. Cosecant squared x times 1 minus sine squared x equals cotangent squared x. Okay, well, cosecant squared, I might say, well, that's the same as 1 over sine squared. We're using the reciprocal identities, okay? And then I know 1 minus sine squared is the same as cosine squared of x. And when I multiply those two, that's essentially cosine squared x over sine squared x. Well, cosine over sine squared is cotangent squared of x. So cotangent squared of x equals cotangent squared of x. We verified, okay? Always show your process as you go through, and then the goal is to try and get it how the right side looks in as few steps as possible, okay? All right, so that should get you started here on verifying the identities, also in 9.7. Okay, thank you.